Hey, this is Steven from LegitTechTutorials, and welcome back to my product development series, or my product design series. We are back looking at the multi-shooter, spooler module and dimensional control module. So we are back working on the software side of those pieces, and we've been working on the from here, we've been working on the variable to calibrate the HX711 filament thickness sensor. So this is what you put into the you put a known filament in there, a known 1.75 or a known 3mm filament, and that basically sets that constant. And then what it will do is it will solve for your spring sensor. So that FT will basically be solved for the spring sensor. So when we solve that, so this is going to be int. Oh, there you go. For filament spring constant, we already have OSP. So this, we don't really need an OSP because we're basically going to be having this thing here, and it's not really going to be a variable that you could. I might right now. I'm probably not going to have it as a variable you could change. You just set it by putting the filament in, you press a button and it sets it. Then you have the spring constant and the FT temp, I don't know what that is. I'm going to have to look back into it. Okay, so filament diameter FT map equals scale, that's the temp. And so then you take the DC is FT MP divided by SC. So the FT temp, the diameter current is equal to FT MP divided by SC. So that's the diameter current. So then that we have that, and this is get value every 5 milliseconds. We have the DC. Okay, so we have that. So now what we need to do is we need to look through here really quick. Motor control, all that stuff. Then we're going to need to modify the first off, we're going to need a variable here, right here, and this is int using using a dimensional control and spooler. So that is, we need a variable that they could turn on and off the thing, so it doesn't try to do the, it doesn't try to set things that it doesn't have access to. So when it tries to send stuff out, it won't actually do that, or maybe you probably don't really need to do that, but the system will freak out and try to manipulate your temperature when you're not doing it manually. So when you're supposed to be doing it manually. So in this, what we're going to change right now is this automatic algorithm, and then this is so this is the automatic mode. So what we're going to do is going to get rid of this piece here, and then we don't really need to do this. So this was originally for the manual mode, which maybe I'll call this manual. That was for if you wanted to do it manually. So basically what you're doing is when it was extruding, you measured the filament, told the controller what it was, and then it would maintain temperature. And then if the filament changed dimensions, you told the controller the new change, and it would actually buffer between and try to get you as close as possible to the new one. Alright, so this is going to be the automatic algorithm, and shouldn't need anything in there. And then here we're going to have, first thing we're going to do is we're going to get DC, and also we're going to need to put the read filament diameter somewhere inside of the runtime here, preferably at the beginning where I read the. So that's the setup. Here's the loop. And then here I need to get rid of this. I need to basically have the controller like reading the temperature every second as fast as it can. Alright, so we're gonna probably put that in for right now. We're gonna put that guy inside of this timer. So it reads the filament size. Alright. So now we're reading the filament size once every timer delay, which I believe, oh, okay, it's I think it's every one second, every 1 second or something. Okay, so I'm gonna say while DC, so this is if DC is less than DT, right? So that basically means if the diameter current, oh sorry, this is greater than, diameter current is greater than DT. So I say if diameter is the current diameter is bigger than target, then what we need to do is we need to drop it down. So what we're going to do with that is we're going to increase the temperature current, right? So we're going to have some sort of here this is going to be the, it's going to be, I'm going to call it the, we call the auto alk. Let's make it start at like, let's make it start at 1 degrees, and eventually this will have its own learning algorithm where it tries to learn the specific material and eventually figures it out. So if current diameter is bigger than target, next one is, what we need to do is we need to set DT DC or DT plus equals, and then this is going to be the, I wish that this had autocomplete, but it literally has nothing. It's kind of annoying. Oh, this shouldn't be an int though. It should be a double. And also another thing that this also should be a double. Okay, okay, we got that. Motor control. And then basically we need to wait a few seconds or whatever before we do something again. And then this is if DT, so this is if DT is larger than DC. If current diameter is smaller than target, then we basically need to drop DT DT minus okay, so basically when the diameter current is bigger than the diameter target, we need to increase the temperature, and when it is lower, the diameter current, we need to lower the temperature. And so basically what we're going to do is this eventually is going to be inside of this here, and everything inside of this here is going to be outside of that. So it just basically does all this stuff. Even though I really don't need this, this, this. It really just needs to be small pieces. This just has a whole bunch of debug lines in it. Okay, so now we're reading the filament diameter, we're doing this, and now we need on the configuration, this is there's no interface on here, I believe. Yeah, so it's coarse Cali, fine Cali, and config. So this one is the AA, DT, AA, TT, TC, etc., etc. So I think this one, DT, DC, shooter. So this is the home page. I could probably delete this and do DC, EXT, heater, config. But we'll leave that for that right now, and we'll modify that later. Okay, so here's diameter target, AA, temperature target, temperature current. So basically another thing on the front page which I need to replace with this, what we need to do on the front page is when you have the heater and the extruder, we need to get rid of diameter target, and we're going to need to move DC up, extruder up, heater up, and then down here we're going to have the this is also so in between here and here we're going to have another button, and the button is basically going to it's going to allow you to turn on and off the to run it, right? Running the auto calibration. So what you're going to do is you're going to have to manually be able to extrude your filament down, right? Extrude your filament down, and then run it into the run it through the dimensional control. So first you turn your extruder on, make sure it's up to temp. Then you're going to pull the filament, and then you're going to let the filament fall. Make sure it's nice and sturdy. Have it go through the dimensional control, and then up and into the spooler, right? And then once you get that going, and you have it extruding a little bit, the diameter starting to become constant, then you hit that button, and it will start the automatic algorithm. And when you hit that button and starting the automatic algorithm is going. Because otherwise, if you start the automatic algorithm from beginning, then you're going to have it's going to be very difficult for you to extrude because there's nothing going through the dimensional control, so it thinks that you're infinitely thin, right? Which is not good because it'll just keep lowering and lowering the temperature, basically turning the temperature off. So you have to get it going, get it running really quick, and wait 10 minutes at the beginning, and then wait be extruding for 5 minutes or whatever. Once you get it attached to the spooler, and then you're like moving the spooler by hand, even though it doesn't really move by hand, then you could hit the automatic algorithm and have it roll the guy into the spool, right? Roll the filament into the spool, and then start taking measurements from the dimensional control. So that is what's going to be on here. Going to get rid of diameter target and put in automatic algorithm right there. And we could actually get rid of this and tell it to do that on the top, and then probably do a button instead, just an on-off button, just like the extruder is working. So we'll change that when we get a chance. But the main thing that we're going to need to do first is we're going to need to add an option to do the calibration on the spring constant, to solve for the spring constant. As another thing that we're going to have to do here is basically I'm going to have it set the spring, solve for the spring constant when you set it, and then set the spring constant. Okay, so blah 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 blah. These are some boxes at the bottom. DT, AA, TT. Does this really need to be there? Yeah, I guess. I'm not even sure if I even had space for it. I can't even remember. I don't think I did. Let me see if I can look through my pictures of what it looked like. Should have it. Should be in here. Save under saved. Saved pictures. Albums. I might have deleted that video. I had a video of it running. Oops. Videos. Oh, that's why I have a whole bunch of failed videos on here. That's why it's taking up so much of my phone space. So right here, please be right. Ah, yeah. I guess I don't have it. Well, anyways, we're gonna put it right here underneath the temperature current for right now. So we're just gonna copy and paste this. And then this is basically that plus 150, so that's 210. But you see here that this starts at 240, so we should have some room. Text size 3, so it might even hit. There's only 3. There's only 30. It might hit. I don't know. This is gonna say spring constant, calibrate spring constant. And then we're going to have, so similar to this, we're going to have a box that's at the height. And then this is going to be 210, the same height, and then over 260. Actually, sorry, this is at like, let's do 190 again. 190 but at 210. So 260 is the bottom, so that's good. That's about another thickness. So that should, and then this one's gonna be like, where are even my colors? What are the colors I had to pick from? Black, blue, red, green, cyan, magenta, white. Maybe cyan then, I guess. I don't know. Cyan, kind of cool color, I guess. Cyan or blue. Let's do blue. Where are we at? Here. Okay, here goes blue. Alright, so when you hit that box, so I need another box control. This is plus, minus, blah, blah, blah. Where's the, here it is. This is a touch handler for page change. So I'm going to copy and paste that guy. And then this is going to be the same as up here, 190 to 10. 190. And then this second part is 210. Oh, 190, 190, and then this is 210, 210. I wrote this little controller algorithm to do the control the box touches. So basically what you have is you have X coordinate, X maximum coordinate. Y maximum coordinate, Y like towards the top of the screen, right? Because as the screen goes, if this is the screen, the XY coordinates are the top is the 0, 0x, 0y. And then if you go over, that's positive x, and you go down, that's positive y. So it's kind of flipped, technically. So this is minimum x coordinate, maximum x coordinate, minimum coordinate, which means it's closer to the top, and this is maximum coordinate, which means it's closer to the bottom. So if it's anywhere within that coordinate system and you touch on the screen, it's gonna hit this thing here. So basically what it's going to do here is, let's go ahead and go back to MOS. They're basically going to grab most of this. This is a touch handler for calibrating the spring constant. So we're just gonna, and then this guy basically returns. When you hit return, it jumps out of this thing, and then so you can't hit anything else. So FTMP is get scale. So this is a force. Turn back on my clock. Where my clock's at 21 minutes. So this is the force. So let's go ahead and put down my equation here. Equation is Hooke's law, which is force is equals to basically was it kx kx, and then k is equal to spring constant, and x is equal to diameter filament. Okay, so we have the force now. Now we know what the spring constant is, because it's basically diameter target, right? I mean the diameter of the filament is pretty much diameter target. So diameter target. Well, we have to assume that's diameter target. I mean, we don't know. So basically, what we're gonna do is we want k, so we're just gonna divide the force. So the spring constant. What does it say? CS? Spring constant? SP. Spring. Spring constant is equal to FTMP divided by, so FTMP is the force divided by dt, and that is the new spring constant. So now once you do that, it will save it. Oh, that's another thing, because I wanted to save that. So I'm going to have to do another thing like this. I have it in here somewhere. Right here. See this one. Okay. So we're going to write this as well. And then I need to figure out which address I have free. So this is basically going to be address 3. Saves the spring constant to EEPROM address 3. So basically what that is, EEPROM is non-volatile storage on an Arduino. So you can store data in there, and when you turn the system off, it does not go away. So it's basically like a small hard drive or a small SD card. It's more like a SD card than it is like a hard drive. So it's just a small piece of flash that you could save small amounts of data to. So you could save a whole bunch of different data there. And I've saved the TT, temperature target, the AA, which is the analog amplifier, the offset for the analog amplifier. I've saved those two. So when you save those two to it, basically I have it read, whenever you turn it back on, it reads the EEPROM and sets those variables to those specific things, right? Yeah. So, that being said, address 3 is open, so I've already used 0. 0 is for the temperature target, or 0 is for the AA or whatever, and then I think 1 and 2 are for the temperature target. So we have address number 3. So I'm going to say this is the spring constant to EEPROM address 3. So when we write that, basically we have to go over here back, and in the read, I'm going to say sp is equal to EEPROM.read3. And then we just basically set sp to that. Now we're done. So now we constantly have, we don't have to set spring constant every single time you turn the machine on. Okay, sorry, I'm reading my text real quick. Okay, so we found the spring constant. So now we need to make sure that we could solve for that. Spring constant. So basically the first time you turn it on, you know, when you have the controller, in that 10 minutes that you're waiting, get a piece of your filament that you want the right diameter for, cut a piece of it off, stick it into the rollers. You know, it has to be long enough that you can stick it into the rollers. When you stick it into the rollers, then you could get the set the spring constant. When you set the spring constant, then you will get the correct diameter current, and then you'll be able to move from there. But for the first part here, the spring constant, I'm going to make this some sort of wacky number. Or yeah, let's just make it 0. As long as I'm not divided by 0. Oh, I am divided by 0. I can't do that. Let's make this 0.1. Now it's going to be a very, very large number. So it's just going to say your diameter is astronomically big, and that you don't want to do that. So you'll know that the spring constant has not been set. All right. So so this is f is equal to kx. This is f, and then this is k. So in order to get x, you're taking the force and you're divided by the spring constant, and you get your x. So there's your x is diameter current. So that's all good. That's working correctly. And so now what we need to do is we need to move these and then add a button for the for your yeah, because that doesn't, wait, or is this a different page? Okay, yeah, this is the right page. So yeah, we should be able to get another one in there. TFT set cursor 0 to 10 again. Do 10, and then this is I'm gonna call this spool, or let's call this auto mode. Oh, that's another thing I forgot. I forgot to put my, just for, oh I did, okay. Auto, and then we're going to need a button similar to the one that does the, that's this one right here pretty much. So copy and paste that. It's going to be, yeah, it's also 190, it's 210, and then it's going to be blue. Oh no, sorry, this is going to be green. So what we're going to have to do is we're going to have to do a similar thing like this is doing here. So let's cut this, and then we're going to do something similar to this. If auto equals 1, I guess that was a definition already. So if auto equals 1, else, then do something else. So if auto equals 1, you're going to do that. Otherwise, you're going to do that. This one's going to be red. It's going to be green. And so we're going to have a toggle also on these. So this is pretty simple to know that the toggle is working correctly. So basically what happens is if it's red, then it's not on. If it's green, it is on, pretty much. And so I need to have a auto on down here somewhere, right here, and auto on is equal to 0. So it's going to start off. We're going to go back over here. So while auto on is equal to 1, then it does that, otherwise it does that, and then we need to go down here to the handle controller, and then this basically sets the screen, which we're almost in the exact same position. So let's go in here, 210, 190, 190, here's 210, 210, 210, 210. Current page, don't want to do any of that stuff. And then I want to do no delay there. Let's get rid of that delay. And it's going to do a similar thing as this. Oh, it has the delay for the button. That's what it is. So I do need the delay. Anyways, if auto on equals 1, I don't know what that is. Auto on equals that. So basically, if it equals 1, it turns it off, and then auto on equals 1. I don't know what this is. And then you need to fill this first draw is equal to false, so you redraw the screen so it changes the color. Alright, that is pretty much it for that. Then all I need to do for the last few minutes here is this guy basically only does its stuff if auto. There you go. Alright, so I'm going to go ahead and save it, and that is it for this video. This has been Steven from LegitTechTutorials, and I'd like to thank you guys for watching. If you liked this video, please subscribe for more videos like in this series and other series as well. I'll see you guys in the next video. Thanks for watching. Take it easy. Peace.